Hello again and welcome to 5-Minute Physics. Today's topic is wires and magnetic fields. So let's picture a theoretical situation. We have two wires. Each of those wires has an electric current running through it. And for this wire, that current is moving in this direction. And for this wire, it is also moving in that direction. That's I1 and I2 for the current. First of all, let's label these B1, B2. Alright. These each has an electric field around it. And because they're pointing in the same direction, the field goes like this for both of them. So if we use the notation that we used when talking about the right-hand rule, where we have the magnetic field coming out of the paper as such, we would have going away from us and coming towards us for that one, and then we would have going away from us and coming towards us for this wire. And as you can see in the middle here, I'll zoom in so you can see that better. There is one field going into the paper and one field coming out of the paper, so this effectively negates the field. So, since there is an opposite charge here and here, these two will attract and be drawn together. And that's very hard to see. There. But these two wires will be attracted to each other because we have charges here of F and minus F. So, the force is attractive if the currents are in the same direction. Alright, well, what about when they're not? What happens when the currents are not in the same direction? Alright, so B1 is still moving in this direction, still got that kind of current. But what if I2 pointed in the other direction, opposite from I1? Then what? In this situation, we have the same kind of thing going on as we did before. We have two magnetic fields, except that this time it's one going this way and the other one going this way. So they're going in opposite directions now. So if we want to use our into out of notation, we would have into and out of. Or actually, no, that'd be flipped. So the other side is the same. So there we go. Into, out of, and in a different color, out of, into. So you have those two magnetic fields. Those will not cancel, they will double. So here we have two positives on the end, so to speak, and some negatives in the middle. So what that means is that we have differing charges. We've got a plus over here, and a minus in the middle. And what happens when you bring two poles together of two magnets? They repel each other, so you end up with the wires being repelled. And there's an F2 going this way, and an F1 going this way. So you can say that the wires are repulsive if the two currents have opposite directions. That's it for today. Thanks for watching, and I'll see you next time.